Hello, I'm Alka Prayakar from VS Polytechnic, Mumbai. In this video, I will discuss architecture of 8086 microprocessor. Learning outcomes. After watching this video, you will be able to first describe what is meant by microprocessor and how it works. Second, explain with sketches the working of given unit in 8086 microprocessor. And third, state functions of the given registers of 8086 microprocessor. What is microprocessor? Microprocessor is a controlling unit of a microcomputer fabricated on a small chip capable of performing arithmetic and logical operations and communicating with the other devices connected to it. Block diagram of a basic computer. This figure shows block diagram of a basic microcomputer. It consists of 4 blocks, namely input device, microprocessor, output device and memory. Here, microprocessor consists of ALU, register array and control unit. ALU performs arithmetic and logical operations on data received from the memory or an input device. Register array. Register array consists of number of registers identified by letters B, C, D, E, H, L and accumulator. Registers are used to store data temporarily. Control unit controls the flow of data and instructions within the computer. How does a microprocessor work? The microprocessor follows a sequence of fetch, decode and then execute. Initially, the instructions are stored in memory in a sequential order. The microprocessor fetches those instructions from memory, then decodes it and executes it till stop instruction is reached. Later, it sends the result in binary to the output device. Between these processes, the register stores temporary data and ALU performs the computing functions. Reflection point. What is the need to study microprocessor family? Stop your video, think on this question, note down your answer and again resume the video. Microprocessor would act as a device brain in that it transmits, receives and interprets the data needed to operate the device. You can say microprocessor can be a heart of your microcomputer. Let us discuss 8086 microprocessor. Features of this microprocessor are: it is an enhanced version of 8085 microprocessor that was designed by Intel in 1976. It is a 16-bit microprocessor having 20 address lines and 16 data lines that provides up to 1 MB of storage. It consists of powerful instruction set which provides operations like multiplication and division which are not available in 8085 microprocessor. It supports 2 modes of operation, that is maximum mode and minimum mode. Maximum mode is suitable for system having multiple processors and minimum mode is suitable for systems having a single processor. It has an instruction queue. It was the first 16-bit processor. It is available in 3 versions on the frequency of operation, that is 5 MHz, 8 MHz and 10 MHz. It uses 2 stages of pipelining, that is fetch stage and execute stage, which increase the speed of operation and improves the performance. It has 256 vectored interrupts. Architecture of 8086. 8086 microprocessor is divided into 2 functional units, that is execution unit and bus interface unit. Let us discuss bus interface unit. Functions of bus interface unit are: provide interface of 8086 to external memory and I/O devices. Transfer data to and from the memory and I/O devices. Fetch opcode from memory. It generates 20-bit physical address using base registers and pointers. Support pipelining using instruction queue, which is of 6 bytes. Bus interface unit contains 3 functional parts. First, instruction queue, second, segment registers, and third one, instruction pointer. Instruction pointer or instruction queue. Instruction queue in bus interface unit gets up to 6 bytes of next instructions from the memory and stores in instruction queue. Execution unit simply read the instruction from instruction queue. Execution unit is executing the instruction. When first instruction is executed and execution unit is ready to read the next instruction, it simply reads the instruction from instruction queue and not from memory. Thus, when execution unit is executing the current instruction, here bus interface unit fetches the next instruction, and this is known as pipelining. Second functional part is segment registers. Bus interface unit has 4 segment registers. Each segment register holds 16-bit base address of that segment. This address is used to generate a 20-bit physical address. CS stands for code segment and stores the base address of the code segment. DS is data segment, ES is extra segment, and SS is stack segment. IP is a 16-bit register used to hold the address of next instruction to be executed. Next is the execution unit. Functions of execution unit are to tell bus interface unit to fetch the instructions or data from memory, to decode the instructions, to generate different internal and external control signals using control system block, to execute the instructions, to perform arithmetic and logic operations using ALU. Execution unit. Execution unit fetches the instruction from instruction queue present in bus interface unit. This instruction is loaded in execution unit, which decodes the instruction. Then control system generates control signals which are given to all the blocks of execution unit. Then this instruction is executed. Here ALU performs arithmetic and logical operations in that instruction. After performing arithmetic and logical operations, result of the operation is again given back to the any one of the register or memory according to the instructions. Then some status conditions are reflected by using a flag register of 8086. Registers of 8086. Registers of 8086 are divided in different groups. First one is general purpose register. There are 4 general purpose registers in 8086: AX, BX, CX and DX. They can be used as a 16-bit register or 2 8-bit registers. For example, AX can be used as 16-bit register, whereas AH and AL are 2 8-bit registers. Second group of register is pointers. There are 3 different pointers as a stack pointer, base pointer and instruction pointer. Next is index registers. SI and DI are index registers, that is source index and destination index. Here pointer registers and index registers are used to store the offset address of a memory location. Next group is segment registers. As we already discussed, there are 4 segment registers: CS, DS, SS and ES. These registers are used to store the base address of a particular segment. By combining base address with pointers and index registers, we can generate a 20-bit physical address of a memory location. Next register is flag register. In 8086, 16-bit flag register is used. Out of 16 bits, only 9 bits are used to indicate the flag, whereas remaining bits are undefined or unused. Out of 9 flags, 6 flags are status flag and 3 flags are control flag. Status flags are used to indicate the status of the operation, and control flags are used to control the operation of the microprocessor. So when a particular arithmetic or logical operation is performed, result of the operation or status of the result of the operation is indicated by these 6 status flags, which is carry flag, which indicates whether carry is generated or not. Then parity flag indicates parity is even or odd. Auxiliary carry flag, zero flag, and sign flag and overflow flag. Then 3 control flags are trap flag, that is a single stepping operation, interrupt flag, that is to enable the interrupt, and direction flag, which is used in string operations. Here, zero flag indicates whether the result of the operation is 0 or non-zero. Sign flag indicates whether the sign of the result is positive or negative, and overflow flag indicates whether the overflow occurs or not after the arithmetic or logical operation. So this is about architecture of 8086. Thank you.